I'm doing competition math, and in this problem we are asking how many ordered pairs of integers m comma n satisfy the equation root n squared minus 49 all equal to m. Now this one I think we can do without actually too much writing. Now you can start plugging in some numbers. Clearly 7 and -7 are possible values for n, where m is therefore equal to 0. All of that makes sense. But if we want to look for other solutions, then, you think about this for a minute. Maybe we want to rearrange and get our variables all together, because it just doesn't seem to be other good ways to solve this. And when we do, we can use the difference of squares to say that 49 must equal n plus m times n minus m. Now we're also going to need this difference to be positive, and so n must be bigger than m. We should also note that if you looked here, you would think that maybe m is allowed to be negative, but just remember where m came from. It is the positive square root of something, so m must be positive where n can, and almost, right, if anything works for positive n, then it also works for negative n, but m must be positive. And this is going to have to be 1, meaning that they are different by only 1. Well, if they're only different by 1, then we could maybe just somewhat intuitively think, well, then they should be pretty close to what you get when you divide by 2. So if you take 49, divide by 2, pretty close to that is what, 24-ish or 25. In fact, we probably want 24 and 25. Yeah, if you add 24 and 25, you get that factor of 49. If you take the difference, then you get 1. So n here, because we said it has to be bigger, n is 25, m is 24. And of course, we already established that if anything works for a positive n, then it also works for a negative n. So we get, basically two solutions, right? With 24 equal to m and plus minus 25 equal to n, we get two solutions to this equation. Let's also think about what happens when we make these 7 and 7. Well, if both of these factors are 7, then it's easy to see that m must be equal to 0. If m is equal to 0, then n is equal to plus minus 7, and we get two solutions that way, and there are no other ways of doing this, so there are in total 4 solutions.